Welcome back. We are in lesson 8 and we are going to learn about area. The area of a closed figure is the number of square units contained in the figure. And a square unit is a square having sides that measure 1 unit in length and 1 unit in width. To illustrate that point, let me draw a shape for you. And let's say that this shape is 4 units wide by 2 units tall. So we would want to find the number of units that it actually contains within the shape. So we can divide here, put a line here. So that's 2 units tall. And then if we divide here and here, keep in mind this is free-handed drawing. It's not exactly perfect, but you get the idea. This is 1, 2, 3, 4 units wide and 1, 2 units tall. Now if we count those, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Now we could do that to everything we needed to measure and find the area of. But there's a simpler, faster way, and I'm sure that you've already identified it, and you're kind of saying it to yourself, and it's multiplication. The formula for multiplication, for area, is your length times your width. And it doesn't matter what these dimensions are, it's the first dimension times the second dimension of your shape, right? So that gives us, because it's a square, it's usually length and width, because a square only has 2 dimensions. It's flat. And area is a 2-dimensional measurement. And that is why whenever we determine whatever the unit of measure is, we say that the unit of measure is squared, because it has a length and a width only, or it only has 2 dimensions. So for instance, in this case, we could have said 4 times 2 equals 8. We would have gotten the same number faster by just doing multiplication, and that is why we do it like this. So let's say this was inches. So 4 inches by 2 inches. Then we would have said 4 inches by 2 inches equals, you take your whole numbers, 4 times 2, and you say 8. And we're going to use on our unit of measure, we're going to pretend there's an exponent of 1. And a little later on we'll be talking about exponents in more detail, but just know that when you have a unit of measure here and a unit of measure here, you add these two together, and that's going to be inches squared. So 8 inches squared is the unit of measure of the area of this shape. Okay? So let's try a different shape, something a little bit more complicated that might blow your mind for just a minute, but you'll pick it up really quick. So this is 8.1, and this is the shape we're going to calculate. It looks like this right here. Oh my goodness, Miss Tracy, how are we gonna, I don't know how to calculate that one either. Hang on. Let's redo this shape. This. All right, there's the shape we're gonna calculate. Let me straighten this up just a little bit. Okay, because these corners are square. All right, so in this shape, we have 2 and 2. And this is 3, and this is 4, and this is 5, and this is 6. Okay, they're giving us all of the lengths of the sides, which would be great if we were doing perimeter. When we're doing area, we don't need all of that. Instead, all we have to do is simplify this into 2 boxes. And then we find the box for the area for the first box and the area for the second box, and we're done. So that's what we're going to do. We're going to break this into 2 boxes, and we're going to try it both ways. And in order to try it both ways, I'm going to make a copy of this. Okay. copy it, and then I'm going to come down here and paste it. Okay, so there's that second copy of that. So for now, let's do it this way. Let's divide this box this way. And what we're going to do is we're going to keep track of the areas by giving it a name. Area 2 and Area 1. I don't know why I named this one 2 and not 1. That's okay. It doesn't matter as long as you have a way to differentiate between the two. So Area 1, let's find the area for Area 1. We have this square here, okay? We can't use the 6 because it applies to the whole thing here. Instead, we use the 4 and the 2 because the 4 stops here, right? So this is 4 long and 2 tall. So we have 4 times 2. That's 8. So the area of A1 is 8. So now let's do A2. And we have a length of 2. We can't use the 3 because it only comes down this far. So we use the 5 because it takes the full length of this side. So it'd be 5 times 2 or 2 times 5. It doesn't matter because the commutative property multiplication says it doesn't matter what order the factors are in. 2 times 5 is the same as 5 times 2, and that's 10. So we add those two areas together, the area 1 and area 2, and the total area is 18. Okay? What if we decided to divide it a different way, Miss Tracy? What if we wanted to divide it this way and make 2 boxes like this? Would our answer be any different? Let's see. Let's do A1 here and A2 here. So in this case, same shape, A1 equals, now we have to use the 3 here because the 3 stops at this point and it's 2 wide. So that's 2 times 3, and that equals 6. And then here, it's area 2. It's 2 tall, 2 is the length, but it's 6 all the way across. Okay, we go from point to point or from corner to corner, and that's 6. We can't use the 4 because that stops right here. We need to use the whole length. So that's 2 times 6. So 2 times 6 is 12. 6 plus 12 is 18. Same answer, even though we broke it up into 2 different ways. Okay? So make your notes. I'm going to clear the page, and then we're going to come back and do example 8.2. So go ahead and pause if you need to write this down. If not, I'm going to clear the page. All right, let's move on to example 8.2. Now, in this problem, we are asked to find the area of the shaded portion of the figure. Okay, and we have a box that looks like this, right? But then in the middle, we have another box right on top of that. And what they are asking is for us to find the lighter shaded portion, the light blue side, not the dark blue side. So we have our measurements here, and we are told that this smaller box on the inside is 6. Let me undo that and get my pen, and then I can write it better. So this section right here, this has got a width of 6, and it's got a height of 2. And then our bigger box on the outside has a length of 10 and a height of 8. So how do we do that? How do we figure out what just this light blue portion is? We have to get rid of this. This is not included. We don't want this part in it. You know, we're getting rid of it. So what do you do when you get rid of something? In math, you subtract. So what we're going to do is we're going to find the area 1, going to be the whole rectangle right here, and then we'll find the area here. We'll find area 2, and we'll subtract area 2 from area 1, okay? So in area 1, we have 8 by 10, right? So that's 80. The The whole thing is 80. Now we've got to take out this section in the middle, this area 2. And area 2 is 6 by 2. So 6 by 2 is 12, right? So now all we do is we subtract the 12 from the 80, and that leaves 68. And that's our answer. Okay? We had to find just the light blue section, so we found the whole thing, and then we subtracted the amount that was represented by this darker blue section, and that was area 2. That was a subtraction problem. All right, so let's move on to triangles, the area of triangles. Fun stuff. If you notice, if you look, I'm going to clear this for you. Pause if you need to take notes, if you're not caught up. If you notice a triangle, I'm going to draw a right triangle for you here. Okay. If you look right here, you can imagine that if you took this triangle and flipped it, you could make a rectangle, right? This is the opposite of this. It's just the other half. Well, that's what a triangle is. A triangle is literally, if you take any kind of rectangle, square, shape, a triangle is half of that shape. That's all it is. So whenever we find the area of a triangle, we treat it like, so the area of a triangle, we treat like a square or a rectangle, and we say length times width, right? But then we divide it by 2, and we take half. And that is true for every triangle. Half of the length and the width is the area of the triangle, because a triangle is half of the length and the width of this rectangle, because we cut it directly in half from diagonal to diagonal, or from opposite corners. So let's try that out. So in problem 8.3, I'm gonna, and this is a formula that you need to write, as well as the area of a rectangle is length times width. Those are both formulas that you need to have on the back cover of your spiral notebook. The area of a rectangle is length times width, and the area of a triangle is length times width divided by 2. Okay? So make sure you have those down. I'm going to clear the page, then we're going to do an example problem with the triangle area. So let's do 8.3. So in 8.3, we have 3 triangles here. Okay. And this triangle is a right triangle, number 1. So this is 90 degrees. And we have, this is 3 and this is 4. All right, this is another type of triangle. And its height is 3. And its width is 4. And then we have another type of triangle here. We have an obtuse triangle. And its height, which is measured from the highest point of the triangle, it's 3. Oops, my pen didn't work great there. This is 3, and its width at the bottom is 4. Okay, so that's how you would measure that triangle. So on both of these, we have a height of 3 and a base of 4. So for all of these, the area of the triangle it's going to be the height times the base, or length times width, however you want to do it. But with a triangle, we tend to call it height and base because the triangle rests on the base here. So 3 times 4 over 2. For all 3 of these, it's going to be the same area. So 3 times 4 is 12 divided by 2, which makes the area of each of these triangles 6, because we can reduce this fraction to 6. Now, because this is in inches, it's inches squared. So the area of these triangles is 6 inches squared. Okay. All right, 8.4. We're given a triangle, and it kind of looks like that. And this is 8, this is 6, and this is 10. All right, and we need to find the area of this triangle. So the area of this triangle equals length times width, or you could call it base times height, either one, divided by 2. It's the same thing, means the same thing. But the base in this instance, which one is the base? So any one of the 3 of the right sides can be designated as the base. And we'll not choose the side of length 10 foot as the base because it would be too difficult to find the height. Because you'd have to do it from here to here. We wouldn't have that measurement here. Right? So we're not going to call, we would have to know what this measurement is here if 10 is the base. So we can't really choose that one. But because this is a right triangle, we know that this is straight up and down. So this is 6 and this is 8. So either one of these could be the height or the base. They're interchangeable. Because it's a right triangle, we don't have to find another measurement. So we never use, this is what's called the hypotenuse. We never use the hypotenuse as the base unless the height here is given. So that means that we're going to say 6 times 8 divided by 2, which is going to be 48 divided by 2, which equals 24. And this is, dimensions are in feet, so it's 24 feet squared. Now, it is important that you do the unit of measure and the exponent of 2 to show that it is area. Otherwise, I won't know what you're trying to say. Okay? It's important when you leave my class and go to another class, when you take the ACT, some of the answers will not have the exponent on it for the purpose of tripping you up. You need to know how this is supposed to be properly formatted. So feet squared is the right unit of measure. All right, so I'm going to clear this page. And if you need to take notes, pause and do so now. All right, let's do example 8.5. In this example, we have an odd shape here. Okay, and we are given the measurements 6, 4, and 10. So we need to figure out how to get the area of the shape. Well, just like with the boxes that we had earlier, and the weird shape with the L shape polygons put together, we're going to do the same thing here. We're going to break this apart into 2 recognizable shapes that we know how to find the area of. So we're going to start with this because this makes a right triangle right here. And we know that this is the height and this is the base because it's a right triangle and it's the easiest one to do. So we know that this is 6 by 4. We'll call this area 1. We'll call this area 2. So area 1 is 6 by 4. And it is a rectangle, so we keep the whole value. That's 24. Okay, and the dimensions of this are in yards. So that's 24 yards squared there. Okay. Now area 2 is a triangle. So we have to say this times this divided by 2. So we know this is going to be congruent to this because it's the same distance. So we can say 4 times, but we need to find this here. So if 10 is the total length and we took off 6 for this part up here, 10 minus 6, this is going to be 4 over here. So 4 times 4 equals 16. And we have to divide that by 2, right? Because it is the area of a triangle. So that's going to be 16 divided by 2. That's going to be 8 yards square. So let's add these two together. 24 plus 8 is going to be 32 yards square. And that is your answer. All right, very good. So let's move on to the area of a circle. Yes, you can find the area of the circle. How can we find it? Well, remember our little friend pi. We're going to use him again. The area of a circle, let me switch pens. I left it on shape. The area of a circle, here's the center of our circle. Here's our radius, letter R there. The area of a circle is pi, remember pi, times the radius square, because it's area, okay? All right. So we say whatever this radius is, we drop it in and we multiply it times 3.14, and we do all of our calculations. So let's do example 8.6. We have a radius of 3 centimeters. So we would say pi times 3 centimeters square, right? So that would be 3 times 3, that's 9 times pi centimeters square. This is a correct answer. You can stop right there. You don't have to go any further. I will accept that as the correct answer. But if you have the need to go further, you like to see the final answer, you can say 9 times 3.14, which is pi. So 9 times 3.14 centimeters square equals, what did I say that was? 28.26. All right, so 28.26 centimeters square. This is also a correct answer. This one or this one. You can stop right here. I'm happy with that. Okay? Or you can take it all the way to here. I'll be happy with that one too. Either one is absolutely correct. So let's try another practice problem. Oh, by the way, before we move on, this is a formula. You need to put it in the back of your notebook. The area of a circle is pi r squared. So that means you square the radius, and to square the radius, that means you say the number times itself. So this equals r times r. Okay? All right. Now I'm going to clear the page and we'll do some more. 8.7. We have the area of a circle that is 25 square meters. So 25 square meters is the area of our circle. We need to find the radius. Okay, we know the area equals pi r squared, right? So if the area is pi r squared, we can say 25 equals 3.14 times r squared, right? So we can divide both sides by 3.14, right? And we end up with 7.96 meters squared equals radius squared. So how do we undo the radius squared? That's pretty easy. We do the inverse operation to both sides. So what that looks like is this. We say 7.96 equals the square root of r squared. So the square root cancels out the square, so that leaves us the square root of 7.96 equals r. So then all we have to do is plug this information into our calculator, right? So we say 7.96, and we get this big crazy number, but we just use the first two decimals. So 2.82. 2.82 meters is the radius. And because it's unsquared because of our radical, right? We unsquared it, so now it's just meters to the 1. So we just leave the meters by itself. So 2.82 meters is the radius. And that's how you would work a problem like that. So we have one more area problem, and it's a doozy, 8.8. Here's our shape, and it looks like this. Yeah, that's not that's not right. Let me redo this one. Okay, there's that. Okay. I'm gonna adjust this a bit right there. All right. Now, my drawings are not exactly square, but they're supposed to be. That's what their intention is. And let me draw a circle here. And the shape actually looks like kind of like that. Get it just a little bit more perfect. There we go. It's about as good as I'm going to get on this. So we need to find the whole area for this. And if this is distracting, let me help you out. So we need the whole shape. So our measurements that we're given are, this is 5, this is 7, and then we have our diameter here, and this is our radius, and it's a radius of 2. All right, so this is what the shape. We have to find the area. So the first thing we need to do is break it down into recognizable parts. Okay, we have a half circle with a radius of 2, so we can go ahead and do that part. This can be A1, right? That's A1. So A1 is just going to be a half circle, and we already determined a half circle. Or actually we determined the circumference of a half circle. So this is going to be along the same lines. We're going to determine that a half circle is going to be the area of the circle, which is pi r squared, and we're just going to divide it all by 2. Okay, that gives us a half circle. So 2 is the radius. 2 times 2 is 4. So 4 pi, right, divided by 2. Now we can divide 4 by 2 and go ahead and get that out of the way. So 2 pi is the area of A1. So A1 equals 2 pi. Now we can go ahead and do that multiplication and say 2 times 3.14 if we want to. But I'll show you how to write this in just a moment where you don't have to do that. So let's break this other part into shapes that we recognize. Okay, so now we have a triangle. And what is the height of the triangle? Oh, I don't know. Well, we've got a radius over here, 2 and 2. That's the diameter. The diameter is the same as the height of this rectangle. So that's going to be 4. And what would this be? Well, we have 5 up here, and that goes from here to here. That's 5. So 7 minus 5, that means this is 2. But as a triangle, so it's half. So area, we'll call this area 2, right? Area 2 is a triangle, so it is 2 times 4 divided by 2. Okay, well 2 times 4 is 8. 8 divided by 2 is 4. So that's the area of area 2. So now we just need to get the area of area 3. Area 3 is a rectangle. All we need is the length and the height. Well, the height is 4 and the length is 5, right? Just for this rectangle here. Because the 7 is for all the way here and included this 2. We don't need that. We just need 4 by 5. So 4 times 5 is 20. So we have area 1, which is 2 pi. We have area 2, which is 4. And we have area 3, which is 20. And what's our dimensions? Our dimensions on this shape is inches. So this is 2 pi inches squared. This is 4 inches squared. And this is 20 inches squared. Okay, we can't just add these together because this has another factor. This is pi here. So what we'll do is we'll add the ones that are alike. Okay, 20 plus 4, that's 24. Okay, and now we have 2 pi. So we need to add 2 pi. So all we have to do is write add 2 pi. Put all of that in parentheses and throw our unit of measure on the end. 24 plus 2 pi inches squared. That is an acceptable answer. Okay, the system will take that and say, yeah, that's right. You did that right. However, if you have a bunch of extra spaces in there, it might accidentally mark it wrong even when you've got the right information. So, if that bothers you, you can go ahead and do this. 2 times 3.14, which is going to be 6.28, right? Inches squared. And because that now looks like this, you can just add it. Instead of this, you can put in 6.28 inches squared, and that's going to be 6 and 4 is 10 plus 20. That'll be 30.28 inches squared. Okay, and that is the correct answer, as much as this one is. Either one of those, the system will take. All right, and that is all I have for, no, it's not all I have. Sorry, I have one more, just one more. No, I have 2 more. I'm sorry. I'm losing my mind. I have 8.9 and 8.10. This was 8.8, so yeah, that's right. So I'm going to clear this page. Pause it if you need to take notes. Let's do 8.9. So 8.9 is a trapezoid, I think. No, it's not a trapezoid. That's 8.10. 8.9 is a parallelogram, which is also known in this instance as a rhombus. All right. So for a parallelogram, you have to find the height, just like for a triangle, because this length here and this length here, if you were to draw a line here and make those 2 triangles, I'm sorry, my pen's not working. If you were to draw a line here and make those into 2 triangles, you would see that that's not the actual height of this shape. Whatever this length here, it's not the actual height. The height is from here to here, right? This is the height. So that's what you need in order to calculate this shape, okay? Now you can use the length of the opposite leg. So you have the length of this leg here, which in this case is 8. Then you can use the height here, which is 4. Now the length of this leg is 5. But 8 times 5 would not be accurate because your area is squished. I mean, that's a technical term, so you can feel free to use it. But you have to have the base times the height in order to figure this correctly. And because there's 2 exact copies, you don't have to divide it in half. You would just say 8 times 4, which is going to be 32. And in this case, it's centimeters squared. So that's how you'd find a trapezoid. You can't use the leg, not a trapezoid, a parallelogram or a rhombus. You can't use the leg, you have to use the height. Okay? So base times height. Same as a triangle for a rhombus. All right, now let's do 8.10. This is the last problem. And this is a trapezoid, and a trapezoid looks like this, right? You kind of have a triangle shape here and a triangle shape here. And if you wanted to, you could absolutely draw a line here and a line here and figure out area 1, area 2, area 3 and add them together. You could do that. But there's a faster way. And that way is to make them into true triangles. And we do that by drawing a line from this side to this side. So now we have a triangle here and a triangle here. And then we just figure out the area for this triangle and the area for this triangle. And then we're done. So our measurements here is the same as for a triangle. We have to find the height. The height is 4. The base on this side is 9, and the base on this side is 15. Okay? So for area 1, we have the base times the height of 4. So that's going to be 9 times 4, and that's 36. And then for area 2, we're going to say the base, which is 15, times the height, which is 4, and that's going to give us 60. So our answer is 96, and it is going to be divided by 2. Why is it going to be divided by 2? Because they're 2 triangles. They're 2 triangles. Now, you could absolutely divide these by 2 here. That's fine. If you want to do it that way and get 48. But if you do it like this, then you only have to divide once. It just saves you a step to add them together and then divide one time. And 96 divided by 2 is still 48. So it's the same answer regardless of which way you do it. I'm just saving you an extra division step by doing it all together. So the dimensions here is in inches. So it's 48 inches squared, and that is the right answer. All right. So remember, the reason that the way we did a trapezoid was we turned it into 2 triangles. The base, each side is the base times the height. Okay, we did that math. And then we divided that total by 2 in one step, just to save time. And that's our answer, because a triangle is base times the height divided by 2. All right. And the reason we didn't do base times height divided by 2 here is because we have 2 identical triangles that would have been added together, so we only needed one area. And that is all I have for lesson 8. I will see you in lesson 9.